Hi, it's time for another math easy solution. Time to discuss further into modeling with differential equations, and now just look at the general differential equations and go over a slightly more formal definition than I went over in my last videos. Basically, in general, a differential equation is, like I stated before, an equation that contains an unknown function and one or more of its derivatives. And the order of a differential equation is the order of the highest derivative that occurs in the equation. And thus the differential equations in my earlier videos on population growth are first order equations because they contain only the first derivative. And then one of my last videos, differential equation developed for the motion of a spring, again those are my previous videos, is a second order equation because it contained a second derivative. And in those previous equations the independent variable was t and represented time, but in general the independent variable doesn't have to represent time. It could be anything you want it to be. For example, we can consider the differential equation right here, y prime equals xy, and in this equation it's understood as y being the unknown function of x, so that's the independent variable, and then the y is the dependent variable. So this is again example of differential equation. Don't need t. It has the it could be x, it could be whatever z or whatever variable you want, and the y right here is the functions, the unknown, and then the derivative y prime. So that's why, and this one's a first order differential equation. And a function is called a solution of a differential equation if the equation is satisfied when y equals f of x. Put a space like that. Actually, I'll put it back. Looks better this way. And its derivatives are substituted in the differential equation. So if we were to plug in the function y and its derivatives inside, and this is satisfied, then basically it's called a solution. Thus, if f is a solution of the above differential equation, thus f is a solution if the derivative of f of x is equal to x times f of x, to get this function like that. Yeah, so that's the only way that this is a solution, if the derivative of it is equal to the same form as that differential equation, so it's x f of x, for all values of x in some interval, whatever you're looking for in your case. So when we are asked to solve a differential equation, we're expected to find all possible solutions of the equations. And we have already solved some particularly simple differential equations, namely those of the form y prime equals f of x, like I showed in my earlier videos. For example, or for instance, we know that the general solution of the differential equation y prime equals x cubed is given by, well, this is just a derivative. So if you look at the integral of it, the solution would just be, well, take the integral, this is going to be x4 divided by 4 plus a constant c. And again, that is a constant. It's an arbitrary constant. And again, this is a solution to it because, again, if you take the derivative of this, that's just equal to, well, this is going to be x3 minus 1, put the 4 down. So you put the power down before 4, and the derivative of c is 0. And then this all equals to this cancels x3. So again, you plug it in, you'll have x3 is equal to x3, and that's our y prime. So again, this is our differential equation. It's a simple one, and this is a solution to it. I'll just circle this like that. Yeah, and now note that in this example, it appears that differential equation y prime equals x cubed doesn't contain the function y, because remember the definition includes y and its derivatives. But indeed, it can be written as, well, you could write this as y prime equals x cubed, and then you could just go plus, well, 0 y. So you could put so then there, it's over there, but as a coefficient of 0. So that's just, that's just one way of looking at it. But you could also think about it as, this equation does contain y because the derivative is there, and this is a derivative of y, which technically does mean it contains it because it's a derivative of it. Yeah, so that's one way of looking at it. Basically, as coefficient of 0, so technically has y. And also to clarify further, the order is the highest order that appears with a non-zero coefficient because, again, technically you can write this function here, you can write it as y triple prime plus 0 y double prime plus y prime equals to x cubed, like that. And again, these are all zeros. So it's the highest order with a non-zero coefficient, and that's this one in this case. So that's a first order. So yeah, it's not going to be third order or whatever because it's all zero coefficients. Yeah, in later videos I'll go over a more precise definition of all of this differential equations, and this is in fact a linear differential equation. Anyways, but in general, because again this was a pretty straightforward solution to this differential equation, but in general solving a differential equation is not an easy matter. There is no systematic technique that involves us to solve all differential equations. And in my later videos, I'll show how we can draw rough graphs of solutions even when we have no explicit formula. And also in later videos, I'll go over how to find numerical approximations to solutions or to approximations or to these rough graphs or to even explicit formulas. And I'll show how to go over numerical approximations, to the solutions of them. Yeah, because oftentimes, most of the time, you will just have to approximate. There's very few real-world applications where you can find an explicit formula and or easy solution that you can't just use approximation to them. Anyways, that's all for today. Hope you learned from this. It's just a basic introduction or just general introduction to differential equations. In later videos, I'll go over more in depth. Anyways, that's all for today. Hope you learned. And like always, you could stay tuned. And like always, you could download these exact notes and link below. Thanks for watching. And stay tuned for another Math Easy solution.